We're now going to talk about the free trade equilibrium and just a little bit at the end about the evidence for the model. So here we are looking at the autarky, pre-trade equilibrium. The home country produces and consumes at point A, and the foreign country produces and consumes at point A asterisk. Once we open up for trade, there'll be an opportunity for both the home country and the foreign country to become better off through trade. Let's start with the home country. So you see the straight line tangency there at point A. In equilibrium, the home country is going to remain at the indifference curve labeled U, and the foreign country will remain at the indifference curve U star. The slope at point A is the relative price of computers. PC over PS is measured in dollars over dollars. So in order to convert everything purely to real terms, we'll cancel out the dollars from the PC over PS and change that to just measuring in real terms. So in real terms, it's actually S over C, shoes divided by computers. So in the home country, shoes over computers is, compared to the foreign country, a relatively small number. So that's like saying if you sacrifice one computer in the home country, you do not get to buy a whole lot of shoes. The foreign country is the inverse case. In the foreign country, if you give up a computer, you're able to change that into a whole lot of shoes. Let's just review real quickly the intuition for why the home country can produce computers in a higher degree than the foreign country, and why the foreign country can produce shoes to a higher degree than the domestic country. The home country is well endowed with capital, and capital is the factor that computer production requires intensively. So the home country is especially well set up to produce a lot of computers. Producing shoes requires a lot of labor, but the home country does not have a lot of labor, and that's why the home country produces relatively few shoes. And the foreign country is the other way around. Now look at the straight lines on each diagram. They have different slopes. That opens the opportunity for productive exchange between the two countries. Just forget about trading for dollars. Let's just talk about trading one good for another good. In the home country, one physical computer does not buy you a whole lot of shoes. But in the foreign country, that computer can in effect buy you a lot of shoes. So starting from point A, in the home country, if the home country cuts back producing computers by 1 unit, and okay, let me rephrase that. Let's imagine we're at point A in the home country. The home country takes just one of the computers it has produced and sends that to the foreign country. That one computer can be exchanged for a lot of shoes. You give the foreign country one computer, they're willing to give the home country a lot of shoes in exchange for that one computer. So the home country is better off taking some of the computers it makes and sending it to the home country, meanwhile cutting back on its own shoe production. The home country has an incentive to specialize more in the production of computers and produce or reduce producing shoes at home. The foreign country works exactly the opposite way. The foreign country has an incentive to cut back on producing computers at home and instead produce more shoes, ship those shoes to the home country, and receive a lot more computers that way. The differing slopes of the two straight lines show you that there is a potential gain from trade of these two countries. This diagram shows the home country after it has started to export computers to the foreign country. So what the home country has done is it started at A, like the previous slide. Now what it's decided to do is reduce production of shoes at home and instead produce more computers, take those computers over to the foreign country. It can exchange those for a larger number of shoes than it could at home, and that's why the pink line has a higher slope than the original slope at point A. Through trade, the home country can rotate that line, that point of tangency, in such a way that it can reach a higher indifference curve at point C. Likewise, the foreign country does the same kind of thing in the other direction. The home country produces more shoes, cuts back producing computers, exports some of those extra shoes to the home country. Bottom line is both countries can reach a higher indifference curve than in autarky through specializing more in the good in which they have the advantage. Now try to imagine that pink line for the home country initially being at the tangency at A. As that pink line starts to rotate, that gap between QC3 and QC2 opens up, and that represents computer exports to the foreign country. So in effect, we can track the amount of computer exports by the home country against the rate at which it trades, the home country trades with the foreign country. You see that pink line of tangency is now rotating. It's becoming less flat. It's becoming steeper. It's approaching the corresponding slope in the foreign country. What's going to happen is both countries will adjust their production and do exporting until both of them have the straight line slopes being exactly the same. That's a point at which the terms of trade have reached their equilibrium, terms of trade being the slope of the straight pink line. And on the right there you can see that straight line which represents what we call the terms of trade for the home country. Terms of trade is the rate at which you have to exchange your export good in order to obtain import good. Initially, at point A in the right-hand diagram, the home country opens up to trade and finds that the terms of trade are really attractive. P C over PS is actually price of computers in dollars divided by price of shoes in dollars. So you take the dollars out of that ratio and what you get is shoes divided by computers. So at the initial point on the left of the international market, the terms of trade are really attractive for the home country. It can obtain a lot of shoes in exchange for a relatively small number of computers. That's the point A. The point A, the terms of trade for the home country are very attractive. Now, as you trade more, as you move from, on the left-hand side, point A to point B, as that pink line rotates to the right, the terms of trade for the home country are becoming less favorable. They may still be favorable, but as that line rotates to the right, the gain from trading more and more with the foreign country decreases. And there's a corresponding movement for the foreign country. Eventually, you'll reach a point, like on the right-hand diagram, like point D, D for Donald. And that's the equilibrium terms of trade. Both countries are trading goods, computers one way and shoes the other way, and they've reached the same point at which they're doing the exchange, the same ratio of trading one thing for the other. Both countries are better off because they're both able to reach a higher indifference curve than they could all by themselves. And that gives you the solution not only for the amount of exporting each country will do, it also tells you what will be the equilibrium terms of trade, the equilibrium price in international trade. Now notice, to get this result and be able to predict what will happen, we actually have to know the tastes for people in each country, which is not something you can actually observe. All we know is that we assume there's a kind of indifference curve in both countries and you will reach the equilibrium. So here is the foreign country counterpart. What we've done is we've taken the foreign country and put it on the left side. You see the foreign country heading there. And the foreign country will go through exactly the same kind of rotation, same kind of reaching a higher indifference curve than it can in autarky, except it's going in the opposite direction, of course. The home country exports shoes and imports computers. Now, in both countries, the horizontal axis is being measured in computers. So the final trade equilibrium will be an equilibrium where the home country computer exports exactly match the foreign country computer imports. So the foreign country has its own line on the right-hand side there, relative price of computers, and it slopes in the different direction from the home country because it is an importer of computers, not an exporter. But those two lines, the blue line for the home country and the blue line for the foreign country, when they cross, you have an agreement. The home country's desire to export computers and the foreign country's desire to import computers exactly match, and that's where you will stop. Implicitly, tastes are affecting the location of the equilibrium because the tastes are reflected in the positions of the indifference curves. So this is equilibrium. Equilibrium is where the foreign imports and home exports for the domestic country are all equal, and you have an equilibrium terms of trade there. And the two countries have optimized their comparative welfare subject to reaching a deal with the counterpart country. So the final result is that in the free trade equilibrium, the home exports computers, which is the good that's using intensively the factor of production found in abundance in the home country, that is capital. And the foreign country exports shoes, which is the good that it uses intensively. Or sorry, I mean the good that uses intensively the factor of production labor found in abundance in the foreign country. And this is the Hecksher-Ohlin theorem. This theorem, or this theory, predicts the direction of trade and what the two countries should be doing to maximize their welfare. This is a summary of all the assumptions you need for this model. So there are a lot of them. And we'll just mention that way back in 1953, the economist Vasily Leontiev actually looked at data for trade for the US to try to see whether this theorem actually worked or was consistent with the data. And much to his surprise, it did not seem to work. He assumed that the US was a capital-intensive country and was trading with countries that were less capital-intensive, and so if the theorem were right, the US would be exporting the capital-intensive goods and importing the other kind of goods. And it did not seem to be that way, and that's why it is called Leontiev's paradox. It was really quite plausible to expect that the theory would work because in 1953, the US probably was the country with the most intact capital resources, by which we mean machines and technology, compared to the rest of the world. Because remember, World War II was not that long ago, before 1953. So this was a surprise. Here's a little bit about his test. And following this, there were several attempts to explain what happened. And of course, if any of the assumptions of the model are violated, that right away would explain why you don't get the result you do. So one assumption for the model is that technologies are the same, which may not be true. It only has two factors of production, labor and capital, which may not be true. And the treatment of labor in the model just treats labor as a very uniform thing, but you could have something called skilled labor and unskilled labor, which would mean you'd actually have three factors of production. You'd need a different kind of model. And it just may be the data is all wrong because World War II had ended just 2 years earlier. And the model also assumes free trade, real free trade, and that may not be a good assumption. So we'll stop there and not dig into the data anymore. And we're going to stop at this point in following the Hecksher-Ohlin model.